Hello everyone. Welcome to the lecture series on health management. We discussed that management methods and techniques are broadly classified into 5 categories: statistical techniques, activity analysis, mathematical techniques, financial techniques, and others or miscellaneous techniques. Mathematical techniques include techniques like simulation study or models, systems analysis, linear programming, inventory control methods, precedence and arrow diagramming, and network analysis. In this session, we will discuss the linear programming. Linear programming is one of the simplest ways to perform optimization, that means maximum profit in lowest cost. It is a simple technique where we depict complex relationships through linear functions and then find the optimum points. Let us understand this in detail with an example. A farmer has 110 hectares piece of land. He has decided to grow wheat and barley. The cost of growing wheat per hectare land is $100 and for barley it is $200. Net profit per hectare from wheat is $50 and from barley it is $120. The man days required for wheat production per hectare is 10 days and for barley it is 30 days. The farmer has a total budget of $10,000 and a total availability of 1,200 man days. He wants to know how to plant each variety in the 110 hectares to earn the maximum profit. Let us solve it. Suppose the total area for growing wheat is X hectares, and the total area for growing barley is Y hectares. These X and Y are called decision variables, means variables which will decide the output. The farmer earns a net profit of $50 for each hectare of wheat and $120 for each hectare of barley. If profit is denoted by Z, then maximum profit, Z, will be equal to 50x plus 120y. This is called objective function. The farmer has some constraints. The cost of growing wheat per hectare land is $100 and for barley it is $200, and farmer has a total budget of $10,000. It can be written as the sum of 100x and 200y should be equal to or less than 10,000. Another constraint is man days. The man days required for wheat production per hectare is 10 days and for barley it is 30 days. The farmer has a total availability of 1,200 man days. It can be written as the sum of 10x and 30y should be equal to or less than 1,200. The third constraint is the total available area, which is 110 hectares. So the equation becomes like sum of x and y should be equal to or less than 100. These all are called restrictions. For all linear programs, the decision variables should always take non-negative values, which means the values for decision variables should be greater than or equal to 0. Means, the values of x and y will be greater than or equal to 0. This is called non-negativity restriction. If we divide the first restriction equation by 100, it can be simplified as sum of x and 2y should be less than or equal to 100. If we divide the second restriction equation by 10, it can be simplified as sum of x and 3y should be less than or equal to 120. The third equation is already in its simplified form. The optimal feasible solution is achieved at the point of intersection where the budget and man days constraints are active. Now we need to draw a graph with all the 3 equations, and the point at which the first and second equation of constraints intersect gives us the optimal solution. Here it is crossing at a point which is matching with 60 at x-axis and 20 at y-axis. So, to maximize profit, the farmer should produce wheat and barley in 60 hectares and 20 hectares of land, respectively. Now we will put these values to the equation of objective function, which was profit Z is equal to 50x plus 120y. Then the resulted value is $5,400. So, if the farmer grows wheat in 60 hectares and barley in 20 hectares of land, he will gain the maximum profit, that is $5,400.